Hello everyone. Today we are going to discuss the significance of water table on bearing capacity. As we have noticed in the previous lecture that bearing capacity is a function of various properties of soil as well as the foundation. Amongst that, water table plays a vital role in determining the value of the bearing capacity. So, as we know, water present in the pore space of the soil helps in keeping the soil saturated, as well as when the soil becomes submerged, then automatically the effective stress on the soil get reduced, which in turn reduces the bearing capacity. So hence we will start with the introduction of the position of the groundwater on the bearing capacity of the soil. If the water table is usually present at a depth less than the width of the foundation, then the foundation bottom will reduce the bearing capacity of the soil. And when the depth is lesser, so it is very hard to build a strong foundation system on the soil, which will have a low bearing capacity. So maximum bearing capacity can be obtained when the water table is at a significant depth below the foundation. So hence we will study regarding the effect of water table on the bearing capacity. So the change in moisture content of the soil mostly affects the property of the soil. So if the soil get submerged, its ability to support the load coming from the superstructure will be reduced when the water table is above the base of the footing. The submerged weight of the soil, what will do, the submerged weight of the soil below the water table will help in computing the surcharge value. Hence, the water table correction factors are mainly determined for finding out the value of the bearing capacity of the soil. So, now, what is the value of the water table reduction factor? Normally, the ultimate bearing capacity of the foundation, as the equation given by Terzaghi, is given by Qu equals to Cnc plus gamma df nq Rw1 plus 0.5 gamma b n gamma Rw2. Here Qu is the ultimate bearing capacity of the soil, C stands for cohesion of the soil, Nc, Nq, N gamma are the Terzaghi bearing capacity equation factors. Df stands for depth of the foundation, B stands for width of the foundation, and the factors Rw1 and Rw2 are nothing but the water table correction factor. So the water table correction factors can be obtained from the following cases. So this is the first case where the position of the water table will determine the value of the reduction factors Rw1 and Rw2. So far the first case is concerned, what is happening? Water table is situated at a depth of ZW from the ground level. So here what will be the value of reduction factor 1 Rw1 and reduction factor 2 Rw2? Reduction factor 1 will be given by 0.5 multiplied by 1 plus ZW1 divided by D, where ZW1 or ZW is the depth of the water table and Rw2 will be equals to 0.5. Hence the equation of the bearing capacity becomes Qu equals to Cnc plus gamma dfnq Rw1 plus 0.5 gamma bn gamma Rw2. Here comes the next case, case number 2, where the water table is located at a significant depth below the base of the footing. So here ZW2 is nothing but the depth of the water table from the base of the footing. So here the value of the RW1 or reduction factor 1 will be given as 1, and the value of reduction factor 2 will be given as 0.5 multiplied by 1 plus ZW2 by B, where B is the width of the footing and D is the depth of the footing. This is applicable on the equation of bearing capacity, that is QU equals to CNC plus gamma D NQ RW1 plus 0.5 gamma B in gamma RW2 for water table situated at a depth of ZW2 from the base of the footing. For the third case, that is when the water table is located at a depth which is equal to or greater than the width of the foundation from the base of the footing, then both the values of reduction factor 1 and as well as reduction factor 2 will be 1, that is unity. So the equation of the bearing capacity becomes QU equals to CNC plus gamma D NQ RW1 plus 0.5 gamma B in gamma RW2. So here in this case there will be no effect of water table on the bearing capacity. So as the water table is situated at a larger depth from the width of the footing, hence we will not consider the reduction factors, or we will not consider the effect of water table on the bearing capacity. So as per IS code method, what will be the value of the bearing capacity? So as per IS code method, the value of the bearing capacity is given differently as stated by Terzaghi. This IS code number is IS 6403/1981. So this code gives the value of the net ultimate bearing capacity, which is more or less similar to the previous equations which are provided by every scientist. The main difference is that only some few other factors have been initiated, or some few other factors have been incorporated in this formula. Otherwise, the basic factors or the basic formulas are approximately similar to the previous bearing capacity equation. So what is the value of the IS code method? The value of obtained from the IS code method, that is QNU equals to CNC SC DC IC plus Q into NQ minus 1 SQ DQ IQ plus 0.5 gamma B N gamma S gamma T gamma I gamma along with a factor W. So here what is the significance of this SQ S gamma SC and as well as DC DQ D gamma as well as IC IQ I gamma? So these are the mainly depth factor, inclination factor and the shift factor depending upon the type of the footing, and the values of NC, NQ, N gamma are respectively given by the Terzaghi bearing capacity factors, and C is the value of the cohesion of the soil. So what are these shift factors, depth factors and inclination factor? These all factors have been provided for the bearing capacity as given in the IS code. So for the continuous footing or strip footing, the value of the shift factors are always 1, that is SQ, S gamma and SC are always 1. If the shape of the footing is rectangle, then the value of the SC will be 1 plus 0.2 B by L. The value of SQ will be 1 plus 0.2 B by L as well. But for the value of S gamma, it will be reduced to 1 minus 0.4 B by L. So for the square footing is concerned, for the square footing the value of SC will be 1.2, for SQ it's 1.2 as well, and for S gamma it will be 0.8. And lastly, for the circle, the value of shape factors will be 1.3. SC, SQ will also be 1.3 and S gamma will be 0.6. These are the value of the shape factor. And what will be the value of depth factor? The depth factor dc will be equals to 1 plus 0.2 d by b root over of n phi. dq and d gamma will be equals to 1 if the value of coefficient of friction is less than 10, and the value of dq and d gamma will be similar, will be equal, whose value will be equal to 1 plus 0.1 d by b root over of n phi, where the value of the angle of internal friction will increase to 10 degree and more, and the value of n phi is given by tan squared 45 degree plus phi by 2. And lastly, the inclination factors. So the value of the inclination factors IC and IQ are given by 1 minus alpha by 90 whole square, where alpha is the inclination of the load to the vertical in degrees, and I gamma is equal to 1 minus alpha by phi whole square. This is the value of IC, IQ, I gamma, that is the inclination factors of the load. And for the effect of the water table, what is the value of the correction factor? The value of the correction factors for the effect of water table is given by W, which is again given by 0.5 multiplied by 1 plus ZW by B, where ZW is the depth of the water table from the base of the footing. So here mainly the water table, if is likely to rise to the base of the footing or above, this value or the reduction factor W is taken as 0.5. So this is the effect of water table on the bearing capacity of the soil.